Lubricating system. The main components of a typical lubricating system are described here. Oil pump. The oil pump is the heart of the lubricating system. Just as the heart in a human body circulates blood through veins, an engine's oil pump circulates oil through passages in the engine. Oil pump pickup. The oil pump pickup is a line from the oil pump to the oil stores in the oil pan. It usually contains a filter screen, which is submerged in the oil at all times. The screen serves to keep large particles from reaching the oil pump. This screen should be cleaned any time the oil pan is removed. Oil pan, or sump. The oil pan attached to the crankcase, or block. It serves as the reservoir for the engine's oil. It is designed to hold the amount of oil that is needed to lubricate engine when it is running plus a reserve. The oil pan helps to cool the oil through its contact with the outside air. Pressure relief valve. Since the oil pump is a positive displacement pump, an oil pressure relief valve is included in the system to prevent excessively high system pressure from occurring as engine speed is increased. Once oil pressure exceeds a preset limit, the spring-loaded pressure relief valve opens and allows the excess oil to bypass the rest of the system and return directly to the sump. Oil filter. Under pressure from the oil pump, oil flows through a filter to remove any impurities that might have become suspended in the oil. This prevents impurities from circulating through the engine, which can cause premature wear. Filtering increases the usable life of the oil. Oil filters are equipped with a bypass valve to allow oil to bypass the filter if the filter is clogged. Oil filters have a check valve. The purpose of this valve is to prevent oil drainage from the filter when the engine is not running. This allows for a supply of filtered oil to the engine as soon as the engine is started and has oil pressure. Engine oil passages, or galleries. From the filter, the oil flows into the engine oil galleries. These galleries consist of interconnecting passages that have been drilled completely through the engine block during manufacturing. The outside ends of the passages are blocked off, so the oil can be routed through these galleries to various parts of the engine. The crankshaft also contains oil passages, or oil ways, to route the oil from the main bearings to the connecting rod bearing surfaces. Engine bearings. Since oil is delivered to the engine bearings by an oil gallery, an oil hole is machined in the bearing for alignment with the oil gallery in the engine block. Oil also flows to the connecting rod bearings. Once the oil has been used by the bearing, it flows out of the oil clearances space and is replenished with a fresh supply of oil under pressure from the oil pump. This oil is then thrown off the bearing surface by the spinning motion of the crankshaft. The splashed oil then lubricates other parts of the engine, such as the cylinder walls and pistons. Oil pressure indicator. The driver can monitor oil pressure by looking at a gauge, which indicates the engine oil pressure at all times, or it can be warning light that will come on whenever the engine is running with insufficient oil pressure. The warning light is the most common oil pressure indicator. Oil seals and gaskets. These are used throughout the engine to prevent both external and internal oil leaks. The most common materials used for sealing are synthetic rubber, soft plastics, fiber, and cork. In critical areas, these materials might be bonded to a metal. Dipstick. The dipstick is used to measure the level of oil in the oil pan. The end of the stick is marked to indicate when the engine oil level is correct. It also has a mark to indicate the need to add oil to the system. Oil cooler. Some engines, such as diesel engines or turbocharged engines, use an external oil cooler. This typically looks like a small radiator mounted near the front of the engine. Heat is removed from the oil as air flows through the cooler. Normal maximum engine oil temperature is considered to be 250 degrees Fahrenheit, equivalent to 121 degrees Celsius. Hot oil mixed with oxygen breaks down, or oxidizes, and forms carbon and varnish. The higher the temperature, the faster these deposits build. An oil cooler helps keep the oil at its normal operating temperature,